Hey everybody, how's it going? Here we've got an A1466 that's not turning on. It's got a bunch of stickers on it. Let's see if we can figure out why this is not turning on, so that this stickered MacBook can go back to its owner and work again. Now remember, you cannot check for image and backlight like this properly, because the machine's going to think it's closed. You need to open it like this. See? Machine is open. And then we test. Alright, so let's see. What do we have for image? Okay, 3 volts on the screen. Now 3 volts on the screen means there is an image. Let's see what we got for backlight. Bam, 8.5 volts. So backlight's not on. So what do I mean by 3 volts for screen and backlight? Or measuring voltage to see if I have the screen backlight. That is an excellent, excellent question. Let's open up the schematic in the board view and go over it. So here we're going to open up the schematic in the board view in Paul Daniels' software, which always seems to, for some reason, default to this useless board view that who has a board on a desk vertically? What is this? I bet when Paul Daniels records his YouTube videos, he records them vertically. Like, what is this shit? Not only does the software default now to opening the board view vertically, but he changed the button. You can't use R to rotate it anymore. Ugh! Awful! Awful! I demand a full refund. Alright, but let's open this page up on the screen. So, when you have no image, there are 3 steps to getting an image. The first is you have to make sure the CPU is on, that you have CPU vCore. The second after that is you have to make sure you're getting an image. Now, the screen is going to negotiate with the machine getting 3 volts sent to it. See this? U8300 is a chip that when it gets EDP panel power is going to take 3.3 volts and shoot it out. So think of EDP panel power as the light switch. Think of this as the electricity going to the switch, and here's the electricity going to the light. So what I was measuring for 3 volts is right here on pin 2 of L8304. If I have 3 volts here, that means that the screen has communicated with the computer, said, hi, I'm a screen, give me power now. I'm this type of screen. I'm the type of screen that Tim Cook wants to have in a MacBook, so work. After that, backlight voltage. PPHV SOSW LCD Backlight. So this over here is going to be backlight voltage, and I got 8 volts. So let's see where that comes from. Paul Daniels says you're a user, so yeah, users are the worst. User and customer are slurs in repair business and in software. I'm the worst customer in the world. I feel bad that Paul Daniels has to deal with people like me. He makes excellent, amazing software. It's just, he has idiots that use it. And the best known person that uses his software is a total fucking moron. Alright, so take a look at this over here. So this circuit is going to take 8 volts. This is going to take 8 volts from PP-G3 hot, which is the battery. Goes through a fuse. Goes through a transistor to turn on. Then this chip over here is going to switch it to ground after this coil. And the faster it switches it to ground after the coil, the larger the spikes are over here as the coil gets angry and rages. So this is the proper scientific definition of how a DC to DC boost circuit works. So just pay attention in case you don't understand how DC to DC boost works. So you have your low voltage and it goes to a coil. Then you're going to have an LED driver. What does the LED driver do? The LED driver is going to switch that voltage after the coil to ground. And when you do that, you make the coil really mad and angry. And then the coil is going to come back with more voltage in the form of a spike than was going into it. So let's say you had 8 volts going into it. As you short the coil to ground right afterward here, it's going to get mad. And then you're going to get spikes of 25 or 27 volts here. And the faster it does that, the more voltage you're going to get. Now, you need that to be saved, because you can't have a spike of 27 and then 0, a spike of 27, 0, a spike of 27 and 0. Your screen's going to wind up giving you epilepsy. What you need is a steady 27. And that's what these capacitors are for over here. These capacitors are like a battery. It's going to store that voltage, and you're not going to have that ripple. It's going to just average it out to a nice, smooth 27 volts. Now, the other problem here is that you have 27 volts over here, but you have 8 volts over here for the battery. So you're storing 27 volts on what is the same straight line back here as what's in the battery. That would be bad. You don't want 27 volts to go back through your entire circuit and kill it. That's what the diode is for. Voltage can go here, but once those 27 volt pulses go here, they're trapped and it can't go back and destroy stuff. And there it is. So because this chip makes that chip mad and go raw and gets angry, you get more voltage, spelled MOAR, voltage. So let's take a look at this circuit. What do we need for this to work? Well, first we need 5 volts in, because over here it says VIN, 5 volts. Next we need it to be told to turn on, just like any light switch. A screen light switch is no different from the light switch in your kitchen. So on your kitchen, you need to flip a switch for the light to turn on, and here you need to send voltage to BKLEN, backlight, enable, in order to get voltage. So I need 3 volts there. And the next thing we're going to need is feedback. So this is going to be making the coil mad, and the madder it makes the coil, the more that we get out of the coil. So how does it know when to stop? Because if it keeps making it mad, we're going to get 50 volts, 80 volts, 200 volts, and the screen's destroyed. But if we don't make the coil mad enough, then we're only going to have 18 volts, 16 volts, 12 volts, and that's not good enough. So the same way that when you're driving, you need to be able to look out the windshield to see where you're driving and what the speed of traffic is, we have feedback over here where the chip is going to see what it's creating. And 2 of the most common causes for there to be 8 volts at backlight is A, feedback is missing. So if the chip can't see what it's doing when boosting, it just says, fuck it, I'm not boosting. The same way, if something covered your eyes while you were on the road, you would stop the car. You're not going to keep driving when you can't see. And the second cause is backlight enable missing. If that voltage is missing, it's not going to turn on. Many people just jump to replacing the fuse, but that's dumb. There's no reason to replace the fuse here because we have 8 volts over here. If this fuse were bad, this fuse is sitting between an 8-volt line and output. If I have 8 volts at output, then obviously this fuse is good. Obviously this transistor is opening. Obviously this coil is coiling. And the diode is dioding. And so on and so forth. And I also know I don't have a short to ground, so there's no use checking this, this, and this. So that one measurement where I see 8 volts over here, the reason I check that before I check the fuse is because it's that one measurement tells me multiple pieces of information that multiple measurements would have to tell me. So I would have to measure continuity of the fuse, make sure that this transistor is opening as a result of this signal and this signal being present, make sure the coil is working, make sure the diode is working, and make sure there's no short circuit to ground. The measurement of whether the fuse is good, whether this coil is good, whether there's a short to ground here, whether this diode is good, and whether there's a short to ground these caps, I actually have an answer to every single one of those individual measurements by doing nothing other than measuring voltage on output. Once I have 8 volts here, there can't be a short to ground, because if there was, there wouldn't be 8 volts there. This diode has to be working, this coil has to be passing, this transistor must be opening, and this fuse must be good. So now I know I've narrowed down my problem to either feedback or enable, or perhaps the chip is bad. And that makes life a lot easier for me. So one of the things I'm doing when I make these measurements, even if you don't understand why I'm making them, why am I measuring the voltage at output rather than the fuse, I want you to understand the thought process behind them so that with other circuits, you can gain an understanding and then make those measurements for yourself based on a thought process you came up with rather than just please borrowing and copying what I'm doing. So hopefully that makes sense. Now we're going to take this apart and take a look at what the board looks like on the other side. And there you have it. Bad LED driver. And I believe the feedback ball is going to be entirely burned. So the feedback ball is going to be the one on the bottom right. Now, as I'm replacing the chip, before I finish getting this off, can anybody tell me why the feedback ball would be the ball that's the most burned every single time there's liquid damage? Why is the feedback ball the one that's always in the worst condition? Why is this one always the worst condition? Higher potential. Great. Good explanation. Yes. That's backlight voltage. Remember, feedback is seeing what it creates. That's the highest voltage. You have 5 volts coming into the chip. You have all these 3 volt enable signals and communication, but 27 volt for backlight is going to be the worst. And you also have switch. The switch. Notice that the switch trace is all at the top is also a little nasty as well. Now let's see if that pad can be brought back in the corner. That's mostly gone. So I'm going to take a knife and I'm going to scrape at the probe point right beneath it. And then we're going to run a wire there. Now these two holes over here are actually backlight output. Check this out. Backlight, backlight. Now that's feedback. So I'm actually going to make sure that that hooks up to there just in case it's broken here. I'm going to anchor it here. Okay, now we're going to cut our wire. I made a little question mark in there. I'm going to stop apologizing because it just makes me more of a douchebag. Alright, let's get that chip on there. Indeed, Kopaz, I deserve to be called a boomer today. What? My chip. We'll green that up later. Let's file this a little bit. Alright, now we see if we have a backlight. Okay, what voltage are we getting at backlight output? 21. 0? Oh yeah, you turned off. Why did you turn off? Why are you taking 30 milliamps? Hey, turn back on, you piece of... Come on. Okay, so we've got 6 volts on backlight. We have an Apple logo. 8 volts there. Alright, it looks like my backlight fuse that was working blew. Let's take a look at the backlight fuse. Because we had 21 volts, and then we had 8, and then we had 6, but then we had 25. So something's funny here. Okay, that's our backlight fuse. There we go. That explains it. Yeah. Wow. Why'd I leave this on the board?
He's got 30 seconds to get all the voices.
Alright, we got a fuse that you could buy off of store.rossmangroup.com if you wanted to. It's right here and ready to be removed. We can remove that fuse. Solder. Solder. Soldering a fuse. Soldering a fuse. Soldering a fuse. Soldering a fuse. For all I know, the fuse is actually good. It's just that pad is disgusting. So lots of scraping to do here. Actually, yeah. What pad? Wow. What pad? Okay, a little bit of scraping, modifying. Aluminium. How do you say aluminium? Aluminum. Aluminium.
Aluminum, don't let him tell you different.
It's aluminium. Yeah, that looks better. I'll do that.
Nice.
Ah. That's some classic Paul Daniels humor right there. There's no U in honor. I like that. Fuck that cat. Did you just fix an iPhone 3?
Yeah. But the guy brought us, sent us a donor with it too. It didn't work. The donor didn't work? No. The donor was actually more sluggish. Nice. You doing? You back?
Oh no, just nasty cat.
3, 2.
Doom. Okay. Do we get a lit up question mark folder? Come on, show me a lit up question mark folder. Let's see, what does the good old multimeter say? If we put the Paul Daniels software on the screen. 25 volts. Yep, that's going to be a lit up question mark folder. 25 volts is a backlight. And there we go. So we have a backlight. So we had a couple issues here. The first problem was that the LED driver chip was entirely corroded. And the main part that fails on all of these is always feedback. The reason feedback fails first is because feedback is where the highest voltage in the system is. That's why it's not a coincidence that always corrodes first. After we replaced the chip and ran our jumper wire for feedback, we also had to replace the backlight fuse. The backlight fuse may have actually been good, but the connection to the board was so badly corroded, and this thing costs like 17 cents, so why not? So we did that. Now we have a backlight. Hopefully my explanation of how a DC to DC boost circuit helped, as well as my explanation as to why I make the measurements I make in the order that I make them to be as efficient as possible. Hopefully this video has helped you. Thank you so much for watching, and as always, I hope you learned something.